Hello friends. So today we are going to do two questions for this waves motion. This question is quite simple. It is a single line question, and so we start with this one. A source of sound of frequency 600 Hz is placed inside the water. The speed of the sound in water is 1500 meter per second, and in air it is 300 meter per second. The frequency of sound recorded by an observer who is standing in air is. So in this question, basically we have to find out the frequency of sound recorded by the observer which is standing in the air. And we have to remember that frequency does not change even with the change of the medium. It means the frequency of the sound source which is inside the water is 600 Hz, and the medium now changes to air, so the frequency is going to remain same. Frequency is not going to change. Okay. So see, this is quite simple. So we start with the frequency. That is our F. It does not change when the sound wave passes from one medium to another. Passes from one medium to another. Okay. Therefore, we can say that the frequency observed in the air is same as the frequency of the source in water. Of the source in water. So therefore frequency of source in water is 600 Hz. So in the air it will be also 600. So option number D is the correct one. D is correct. And the second question for it, we are given that a closed organ pipe of length L and an open organ pipe contains gases of density ρ1 and ρ2 respectively. The compressibility of the gases is equal in both the pipes. Both pipes are vibrating in their first overtone with same frequency. The length of the open organ pipe is. So in this case we have two organ pipes, one is closed and the one is open, and we are supposed to find out what will be the length of the open organ pipe. So let us write few things which is given in the question, and then we are going to move forward. So we can say key conditions and assumptions. Key conditions and assumptions. First, it is given that both pipes are vibrating in their first overtone with same frequency. And remember, we have two pipes. One is open, another one is closed. So we are given that both pipes vibrates at the same frequency in respective first overtone at same frequency and in first overtone. Second is given the compressibility of the gases is same. Second thing is given that compressibility of the gases is same in both pipes. So we can write that the speed of the sound equation, so you can say the speed of the sound if it is given as V will be equal to 1 upon square root of compressibility multiplied by their density. So compressibility in both the cases is same. So we can write this formula in terms of closed as well as open depending upon their densities. So we can say for closed organ pipe, velocity is V1 and V1 will be proportional to square root of density, that is rho 1. And for open organ pipe, velocity is V2, that is directly proportional to 1 upon square root of rho 2, that is density, because compressibility is same. So we can find out ratio V1 by V2. V1 by V2 will be equal to square root of rho 2 divided by rho 1. This relationship we are going to use later on. And we are given that the length of closed pipe is L. We are given length of closed pipe is equal to N, and we assume that the length of open pipe is L naught. So let length of open pipe is L naught, and it is also given that both are vibrating in their first overtone. Okay. So we can write the formula that frequency for first overtone if it is represented as F, then the F will be equal to harmonic number multiplied by velocity and divided by wavelength. So we have two pipes, one is open and another one is closed. So let us consider first closed pipe, and for this closed pipe we are going to modify this formula. Okay. So we can say Therefore, for closed pipe, the first overtone corresponds to third harmonic. So we can say therefore for closed pipe, the first overtone corresponds to third harmonic. Therefore, we can say the harmonic number which is supposed represented as n will be equal to 3. Therefore, we can write the formula that F closed will be equal to 3 multiplied by velocity V1, and we have this as 4 multiplied by L. Sorry, it's not wavelength but length. My mistake. Okay. And where V1 is the speed of sound for gas having density ρ1, and L is the length of the pipe, closed pipe rather. L is the length of closed pipe. Similarly, we can write it for, this was for closed pipe, so same we write for the open pipe. You can say for open pipe, the first harmonic correspond to, the first overtone corresponds to second harmonic. The first overtone corresponds to second harmonic. So it means the harmonic number will be equal to 2. You can say therefore harmonic number n will be equal to 2. So we can write the formula now. Our F open will be equal to 2 multiplied by V2 and divided by 2L0. This gives us V2 upon L0, where V2 is the speed of sound of gas having density ρ2. V2 is the speed of sound having density ρ2, and L0 is the length of open pipe. L0 is the length of open pipe. But it is given that both pipes vibrate at same frequency. So we are given that both pipes vibrate at same frequency. Therefore, F closed will be equal to F open. F closed is equal to F open. We substitute the respective values and we get this as 3V1 by 4L is equal to V2 divided by L naught, and we are supposed to find out L naught. So therefore we can write this as our L naught will be equal to, this comes as V2 by V1 multiplied by 4L and divided by 3. And V1 by V2 we already know, so you can see, but V1 by V2 we calculated as square root of rho 2 divided by rho 1. So we just reverse it. V2 by V1 will be equal to rho 1 upon rho 2. Now this is L naught. So we get here L naught is equal to square root of rho 1 upon rho 2 multiplied by 4L divided by 3. So we can just rearrange it. We can say L naught will be equal to, we are given the option as 4L divided by 3, and we have square root of rho 1 upon rho 2. This is the length of the open pipe. This is the length of open pipe, and the option that is given to us is our 4L by 3 rho 1 by rho 2. Option number C is the correct option. Option C is correct. So this completes the question. Thank you.